there is a very effective variant of decision trees. It's a generalization algorithm. It's called random decision forest. The basic idea there, it's a fairly simple idea, but it ends up being surprisingly effective. So what you do is, instead of growing one tree on your data set, you're going to grow k different trees. And the way you get different trees is you randomize the input to the IDA3 algorithm. So what you do is you take your set of examples, you pick a random subset SR, and then you use that SR to learn to build a full decision tree. So you run the ID3 algorithm, you don't do any kind of pruning, and just from that subset of the data, you build an entire tree with one caveat. So whenever you're doing the splits, you don't use all the attributes, you pick a subset of the attributes. So you're using a subset of the data, subset of the attributes, build a full tree from that. And then when you're testing, when you're computing gain, that gain is computed over a subset, naturally. And then you do the same thing k times over and over again. And because you're using different random subsets of the data and different subsets of the attributes, you're going to end up with k different trees. And then you put them together in a very straightforward way. So when you have a new data point, you give that data point to each one of the k trees. Each of the k trees is going to produce a classification, and then you take the majority vote. So you take the class that was predicted most often among the k trees. So it seems like a really simple algorithm. Really, all you're doing is you're just randomizing the input to a decision tree and then averaging it. Surprisingly, it gets state-of-the-art performance in many, many different domains. So I think one of the success stories for decision forests was the Kinect. The decision forests were used for recognizing the movements. So it's actually a pretty cool thing. And because decision trees are efficient, you end up with a very efficient implementation. Again, even once you have to train many, many trees, because they all are very small.